Columbia and the satellite now 77 nautical miles apart. Again, that call reporting that the crew can see the tether and see the satellite. That it's beautiful. This view showing the satellite. Again, just moving into sunrise. 81 nautical miles now from Columbia.
Guys getting the image?
Franklin, we see a long line, a couple of star-like things, and a lot of things swimming in the foreground. Can you describe what you're seeing?
Well, the long line is a tether, and there's a little bit of debris that kind of flies with us, and it's illuminated by the sun at such low angles. So there's a lot of stray light, and it's getting washed out quickly, but Claude is trying to do a quick, good job here adjusting the cameras.
Copy that.
In that description by the crew, this is the tether in the satellite with approximately 12 miles of tether still attached to it. Columbia and the satellite are now just passing over the west coast of northern Africa. The two spacecraft are now 90 nautical miles apart. Controllers for the satellite did have communications with it during the close pass between Columbia and the satellite.
Columbia, Houston, that's a much better view, a lot more contrast visible. And how wide does that tether appear to be? It seems to resemble a much wider strand than we'd expect. Can you describe which way the satellite is visible on that strand?
Satellite now 100 nautical miles.
Charlie, completely unzoomed, and you see the full extent of the tether. I try to adjust the focus, but I can't get better than that.
Okay, Claude. Thank you.
I'm going to zoom in now.
STS-48 captures an object that changes direction in an instant. And STS-114 films an object traveling a very unusual path. But in the case of STS-75, the team finds the footage so compelling that they seek insight from experiment's producer, John Tyndall.
Today we're going to demonstrate a difficulty that three dimensions being captured by two-dimensional cameras.
John believes this experiment will shed light on the images captured by STS-75. A tether broke off from the space shuttle and was seemingly surrounded by small orbs. He has set up a spatial representation of the tether and the windows of the shuttle.
All right, now you can see that's the tether. It's broken loose. See those little snowflake or those disc shapes going right behind the tether. Now, other ones are appearing to be in the foreground, which leads a lot of folks to believe that they were real and they were out there.
These particles may be nothing more than ice and debris from around the ship that are out of focus because a telephoto lens was used.
NASA maintains that this is nothing more than ice and debris that's around the ship that's out of focus because this is a telephoto lens. Now the camera was using a lens, a telephoto lens, which incorporated a mirror. This hole that's in the center of this mirror would also leaves an artifact, the same artifact that you see in the discs.
Light illuminates these objects from behind, and then this light bounces off the mirrored lens. The objects will now appear to have the form of the lens, even though this is not their actual shape. This can be seen by Tyndall's example. He has prepared a small piece of fishing line that is backlit by a green light. However, when the line is passed in front of the camera, it doesn't look like fishing line. It takes the form of a circle with a hole in the center.
Sunlight was coming across and hitting ice crystals and backlighting them and causing them to illuminate. Any shape that's around the lens of a camera or around the optical path will impinge on those circles of confusion.
But even if the object's shape can be explained, why do they appear to pass behind the tether and circle it? John has set up a mock tether inside a three-dimensional environment and will show how this optical illusion occurs.
You see how overexposed the tether is at this point? Even though this is in the foreground, it gives the illusion that it's passing behind.
The image on STS-75's camera is overexposed, meaning that objects appear brighter than they actually are. Illusion that they are behind the tether when they are actually in front.
So you mimicked a UFO?
Yep.
Okay.
I think John Tyndall did a good job demonstrating a number of potential optical aberration effects that you might see in the conditions of taking photographic or videographic imagery through the space shuttle windows.
The team successfully recreated some images from the STS footage, but others still remain unexplained.